This is a key to the worksheet on topic 8, part A, and this is where you want to graph these linear equations. Now, number one, you wanted to use a t-table, and in number 2 and 3, you had to use slope and intercept to graph. So it's very important that you read the directions when you're working on these problems. So number one, we have this equation. We have y plus 3x is equal to 2. And so we have this linear equation. Now remember when you graph a linear equation, your graph is a line. And in number one, it says choose 3 values of x and find the y value. So you wanted to use a t-table. So I had to see a t-table in number one. So what I would do first though is it's very easy to get y by itself. So let's go ahead and do that. So I get y equals negative 3x plus 2. So if I subtract 3x from both sides, this is what I would get. And then I'm going to use a t-table using this equation. So you have your t-table x value, y value. So I'm going to pick 3 values for x, and I'm going to find the y value. An easy number to use for x would be 0. So if x is 0, I get y equals negative 3 times 0 plus 2. And negative 3 times 0, 0. 0 plus 2 equals 2. So I'm going to plot the point 0, 2 at some point. Then in the next one, we have x is 1. So let x be 1. So I have y equals negative 3 times 1 plus 2. So that's negative 3 plus 2, which is negative 1. So I put a negative 1 here, and then if we say let x be, in this case, negative 1, I get y equals negative 3 times negative 1 plus 2. And so I get negative 3 times negative 1 is 3. 3 plus 2 is 5. Now, all of these points, if I did this correctly, all those points should lie on the same line. So they should all be collinear. So I'm using the word collinear. So meaning that the points lie on the same line. So you had to do this by hand if you didn't have grid paper. So it would look something like this. And so you would, now remember it did say in the directions, make sure you label your points. All right, so you have 0, 2. So let's say this is 0, 2 here. So I'm going to label that point 0, 2. So 0, 2 is on the y-axis. So this is your x-axis. This is your y-axis. And then 1, negative 1 is, so you remember to graph a point, to plot a point, you start at the origin. So you go to the right one, down negative 1. So you make sure you show those marks right here. And so there's the point, 1, negative 1. And then make sure you scale it as good as best you can so it looks like a straight line. And then negative 1, 5. So negative 1, 5. So negative 1, 2, 3, 4, 5 is here. So let's label the point negative 1, 5. And then notice that negative 1, 5 is in the second quadrant. And so I'm going to go ahead and draw my line going through those points, and make sure you draw your arrows. I do need to see those arrows, and there's your graph. So you have this line. Now I want you to remember something. You now have enough knowledge to know that whenever y is by itself, this is your slope. The coefficient of x is your slope. And notice that the slope is negative, so the line should fall. Okay? But you had to use a t-table for this problem. All right, now number 2, we have this. We have y equals negative 3 halves x plus 5. Now, when doing number 2, the direction says this, and it's very important that you read the directions. The direction says graph the following using slope and y-intercept. In your work, indicate the slope and the y-intercept, and then graph. So this is already in slope-intercept form. So remember, slope-intercept form is this. It's y equals mx plus b. So whenever you get y by itself. Now, the coefficient of x is your slope. So in this case, the coefficient of x is negative 3 halves. So there's your slope. You had to indicate it. That's what the direction said. So you had to indicate, you had to write out what the slope is. And then the y-intercept, b, would be the constant, which is 5. And the y-intercept, that's where the graph crosses the y-axis. Now, the direction said use this information to graph. Do not use a t-table. So I did not want to see a t-table. I wanted to see this information being used. And here's how I can tell that that's being used. Okay, so look at how I can tell if you're using this information. Okay, so let me go ahead and draw the x and y axis. And so remember, to graph a line, you need 2 points. So one of the points is this y-intercept. That's where the graph crosses the y-axis. So I'm going to go 1, 2, 3, 4, 5. Okay, and then the slope is a -3/2. So remember, it's -3/2. The slope is rise over run. So basically, you have to go down 3. The rise is negative, so you have to go down 3. 1, 2, 3, and then to the right 2. 1, 2. And so basically, if you were using slope-intercept, if you were using a slope y-intercept, I would see this point here. So I would see you tell me that this is the point 2, 2. And this is a 0.05 because it did say label. Now you could have also done this. I just want to remind you. I want to remind you this. So you could have said 3 divided by -2 instead of -3 divided by 2. All right. So in that case, you would have done this. You would have done up 3, 1, 2. I got to extend this a little bit further. 3, and then to the left 2, 1, 2, and you would have gotten this. And so that would have been the point -2, and then that's 5, 6, 7, 8. So that's 8 right here. So that would have been the point -2, 8. So either one of those points would have sufficed. Okay? And then all you do is you draw your line and you're done. So you have used, now remember, it's not scaled very well because I'm doing this by hand, because that's what most of you are going to have. You're not going to have grid paper. Um, so so that's what you have. So, and notice that the slope is negative and the line is falling. Okay, so that's how I can tell if you're doing slope-intercept. If I see a t-table, then that implies that, and I don't see you indicating what the slope and y-intercept is. That definitely implies you did not follow the directions. You did not use slope-intercept. And then finally, number 3. So this is what you would have done in number 3. So number 3, you have this. You have -5x plus 4y equal 12. Now read the directions. The direction says graph the following using slope and y-intercept. Write the equation in slope-intercept form, and then your work indicate what the slope y-intercept form is. Okay, so to get slope-intercept form, remember in the previous problem we indicated slope-intercept form is y equals mx plus b. So you had to get y by itself. So let's go ahead first of all and add 5x to both sides. And so when I add 5x to both sides and combine like terms, I get 4y equals, and let's put x first, the term x first. So 5x plus 12. Then to get y by itself, you can divide both sides by 4. And so when I divide by 4, I get 4 divided by 4 is 1. 1 times y is y. So I get y equal, and let's put this as two separate terms. So 5/4 x, 5/4 x, plus, and then 12 divided by 4 is 3. And so that's your slope-intercept form. So you had to show this, so you had to indicate this, so that's the slope-intercept form. So that's one of the things I had to see based on the directions. Slope-intercept form. All right, and then now we know the slope, so the slope is 5/4. So the slope is positive, so that means your line is going to rise. Okay, and then the y-intercept is 3. And then we do the same thing. We're going to use let me go ahead and do it like this. So here's the x-axis, here's the y-axis. So to graph a line, I need 2 points. So one of them is the y-intercept. 1, 2, 3. So that's 0, 3. And then we're going to use the slope. Remember, the slope is rise over run. Rise over run. And so I'm going to go up 5. 1, 2, 3, 4, 5. And then to the right 4. 1, 2, 3, 4. Now I wish y'all had graph paper so make it look a little bit better. But since we're doing virtual, the best we can do is by hand. But I do need to if it doesn't look right, you need to erase and make it look right. So make it scaled as best you can. Because if you're just putting something on there and it doesn't look like a straight line, you're not going to get full credit. Okay, so that's the point 4, and then I was, remember this is 4 here. Okay, that's 4, and then that's 3, 4, 5, 6, 7, 8. So that's 8. So this point, you got to label it. That's going to be 4, 8. Now, I just want to say something. So remember the slope is positive 5/4, right? Okay. Someone else could have said, well, instead of saying positive 5 divided by 4, I'm going to say negative 5 divided by negative 4. Okay, that's fine, because that is still a positive 5/4, right? They're equivalent. So in other words, what someone could do is I don't know why they would do that, because it makes it look a little bit more complicated, but I just want to remind you. So this is still correct. A negative 5 divided by negative 4 is still a positive 5/4. All right, but I'm going to use this here to find the other points. I'm going to start here. I'm going to go down 5. 1, 2, 3, 4, 5. And I'm going to go to the left 4. 1, 2, 3, 4. Right here. So there's the point. So this is negative 4. This is negative 2. So there's the point. If I label it, there's the point negative 4, negative 2. And then notice, and I didn't scale it very well, so that would be something I would erase to make it look better. But here we go. There's the line. There's the line for this equation up here, negative 5x plus 4y equal 12. And remember, I can, if I want to, and you wouldn't do that because there's no reason to do that, but you can continue going up. Watch. You can go, using this, you can go up 5 to the right 4. You get another point in the line. Up 5 to the right 4. You get another point in the line. So using the slope, you can get an infinite number of points on that line. All right, but I did not want to see t-table. It did not say use a t-table. So this right here definitely implies that you used the slope-intercept. It definitely implies that you follow directions. Okay, so that is the key to the worksheet on topic 8, part A.